here. All right, so square root functions, last part in our first unit of new stuff. So basically what we're going to do is we're going to take a look at some of these graphs and notice A, what the domain and range are, and B, just some simple ways to make graphing these a little bit easier, even though the calculator does make it pretty simple. So, speaking of the calculator, if I go to make a graph of any of these, so again, I'm going to go ahead and graph, excuse me, this first example we've got up at the top. Again, most of you are familiar with these, but if you're not, to get your square root, you're going to use second and x squared to get the radical. And then we'll just do the 3x minus 2. Close my parenthesis up just to say. And then when I get here, I can look at a picture of it, okay, is one way I can look at this to try and come up with some of my values. But the way that's actually a little more powerful when it comes to this, because I can see kind of that it's going to go off forever to the right and go up. But as far as the beginning of my domain or range, it's kind of tricky to tell from here where that's going to be. So what I'm going to do is I'm going to come to my chart. And here's the nice thing about it. If you start to go towards the negatives, you notice I start getting errors for all my y's. You're like, why is that? You know, what's the deal here? What the deal is, any x value that I plug into this radical and it ends up making my value come out negative is going to be undefined because, well, if it's a negative number, that's imaginary. That's when we get into I and all that other fancy stuff. So one of the nice things about the chart is you can see where those error messages start to know, ooh, I better not have any part of my graph there, so I can go ahead and start working it that way. So I take a peek here, and I may not notice right away because you're like, well, the table they have, they got it 2/3. Now, why would they start there? Because mine are all, 1, 2, 3, and so on. This does a good job of telling me what my x value, okay, or what my intercept or where my domain would start. So for this particular one, my domain, oops, there we go, would start at 1, where I'm actually going to get some values. And I'll show you some cases where it could be fractional too. But since it starts at that, I'll use a bracket. And I notice my graph, even looking at it here, is going to go forever and ever to the right. Now, again, here's an issue that I'm going to come into, and one that I just saw I noticed myself get into here. I'm like, well, Harty, why are you using 1 when it could be 2/3? That's my intercept. Let me rewind to do one thing that'll make your domain finding a little easier if you get something like this. My apologies. I got a little distracted. When I'm looking for my domain, basically I want to make sure that this is 0 or greater. So let's do one quick rewind here. If I take 3x minus 2, okay, and make sure that it's at least 0, that's where my graph's going to start. And I'll explain this way where this x value is coming from. So if I add 2 to both sides and divide by 3, that's going to be my beginning x value. So in contrast to what I had just said, I now officially get to put my foot on mouth for the World Wide Web to see. I need to start where that x-intercept is at. But most of the time we don't get into things that are real complex with these because we just want to get a basic idea of what's going on. Okay. So my x-intercept, whatever setting what's under the radical equal to 0 gets me, is basically where my domain's going to start for most of these. We can get some shifts, but that's going to be the case. Okay. My range will start at the y value of whatever that x is. So that starting point is going to be the same thing that's going on with my range. And again, it mentions here the range is going to be y is greater than 0. So my range is going to go from this value, and again, it'll keep going up and up and up forever off to infinity. So as far as domain and range go, that brings it pretty straightforward. Whatever below here, set equal to 0. Find my intercept, gets me domain. The y value at that value is going to be my range. But here's where I think things tend to get a little bit trickier, and I want to make them more simple. Let me bring this back up, you'll notice on here, a lot of times you're going to get a lot of decimal answers, and that can be kind of tricky to graph real accurately. So here's one thing I want you to take notice of, and I'm going to take a note of here myself. You're like, okay, where do the values seem to be the simplest on this one? Well, I'm like, okay, I get whole numbers at 1 and 2. Let's see where else some whole numbers come here. 6, okay, and 9. Let's just start with those. Now let's think about what happens when I plug those in to here. And I'm just going to put those values underneath. If I plug a 1 in here, 3 times 1 is 3, minus 2 is 1. Okay, 3 times 2 is 6, minus 2 is 4. 3 times 6 is 18, minus 2 is 16, and 3 times 9 is 27, minus 2 is 25. Interesting. What do all those red numbers have in common? They're all perfect squares. So when you're trying to graph these, if you don't have a graphing calculator available to you, my suggestion is you need to use numbers to plug in for x that are going to make what's underneath a perfect square, because then you're going to get whole number answers out every time. Now, if you got the calculator, shoot, go ahead and use it. I mean, I'm not going to tell you not to, but that's something that you can do. So if you can create square root of 0, square root of 1, square root of 4, something like that underneath, that's going to make your graph that much more accurate and a little bit easier to work with. So as we move down here a little bit, all right, graph each function, describe any transformations, shifts, we'll get to that in a minute, and state the domain and range for each. Okay, so again, I like to use the one that comes out as whole numbers. So if I'm going to go to the graphing calculator, and this is one where I can show you both ways to make it a little bit easier. All right, we'll clear that out. So second x squared for my square root, get my x, and I'm just going to go ahead and use the table right away. Now again, this is me. When I'm doing these, and you don't have to draw the chart every time, I just do so I can see what's going on. I like to use the ones that come out clean with whole numbers, because it's also going to help me start figuring out what some of the mental math would be if I don't have a graphing calculator sometime. The world doesn't have to end. So I notice this time, oh, it's the square root of x. Notice all my x values. They're all perfect squares. So once I have that, I'm going to plot those points. And get an arrow going from there. That first point that I draw, okay, whatever makes my radical equal 0 is where I want to start. And sometimes that'll shift things around a little bit. But again, we'll start talking about that as we do some more. But I don't want to have arrows going both ways. This isn't going to keep going and going this way forever or anything like that. So once I get it drawn, and this is like my base graph, it's like my mother graph of sorts. When I go to do my domain and range, I look to wherever that first point is at. Since my first point's at 0, 0, right there, that means my domain value is starting at that x value, 0. My range is starting at that y value, 0, which makes sense. Here's my furthest left point on my graph. Goes off to infinity. It's my domain. Here's my lowest point on my graph. It goes up and up and up forever. My range. So there's a direct correlation between those, between your starting point and where your domain and range are going to start. So let's see here. Now this one, a little different. This time I've got 2x in there, the square root of 2x. And again, I want to keep working both of these so we can get the point in case sometime we don't have a graphing calc. So I bring my table up again. Okay, I see my error message. I don't want to go there. And I start thinking again about, okay, I want the whole number ones. So 0 gets me 0. 2 gets me 2. Let's see if I got any others that are going to fit in the graph here. Okay, and 8 gets me 4. Might not always get 4 points. But again, go back and look at what those x values get you as a value underneath. 2 times 0 is 0. Okay, that makes sense. 2 times 2 is 4. Perfect square. Comes out nice. 2 times 8. Perfect square. Comes out nice. That's what I mean on finding points instead of just trying to do all the little decimal stuff. Because if I use those and play connect the dots, I notice my graph widens a little bit. It gets a little bit stretchy for me because I've got a larger value in front of my x. But notice my starting point didn't change. It's still at 0, 0. So even though my graph stretches, it doesn't have any impact on my domain or my range. Because again, it's that starting point that directly relates back to my domain and range. And yes, that will change, but we're sort of going to slowly work our way to that point. You're like, now wait a minute, 3, the only difference is from 3 back to 1, negative in front. What effect do you think that negative's going to have on your graph? Yeah, it's going to open down instead of opening upward. So I can put this in the middle so I can see them both. So I've got a negative square root of x. And see, yeah, it just takes it and basically it mirror images it over the x-axis. But again, I can look at my values. And we're just trying to reinforce here. You're like, oh, it's the exact same x values that I had for number 1, except now they're all negative y's that are coming out. So it's this guy, except basically I've flipped it over and have it opening below the axis. But does that change anything as far as my domain and range go? Well, I do understand that I'm still originating at 0, 0, but let's think about this for a minute. Is this still my furthest point left? Sure. Okay, so my domain is still 0 to infinity because it's going to go off forever to the right. But range, we got to think about this for a minute. Is this my lowest point anymore? No, now it's my highest point because every point after that's just going to keep going down, down, down. So how am I going to tweak my range a little bit? Yeah, negative infinity to 0. So that negative tweaks my range a little bit here. My domain seems to just keep chugging right along here, but my range had a little bit of an issue on that one. So it's something I've got to be careful of. Then it really starts getting fun. You're like, uh-oh. Now the negative moves inside the radical. Now some of you say, wait a minute, you just said a minute ago, a negative inside the radical you can't do. It's undefined. That's true. I don't get real number solutions for that. So let's see. If I go ahead, I'm going to plug this in and try anyway and see what happens. All right, let me hit the graph button. Oh. Now instead of reflecting over the x-axis, now it's the same graph except it's reflecting over y. So but what values are going to work? Where are those all coming from? Well now, all the errors are in the positive numbers. All of my values that work now have gone into negative x values. So there's the difference of the negative being inside or outside. My 0 is still going to be 0, but that's the only one that's the same. Now basically what's happened is I can either look at it as I have the same exact y values as I did up in number 1, except everything now is shifted to the left. And the nice thing is we'll always have the calculator in here as a backup in case we try one of these and something doesn't work out. Okay, not as wide as like number 2. But let's see, now what's that going to do to my domain and range? Let's see. Is this point now my furthest point to the right anymore?
Yes. Furthest point to the right.
Is it my furthest point to the left, though, which is the question I actually meant to ask? No, I was thinking ahead, dang it. But it's the furthest point to the right. So that's where my graph will finish for its domain. But it starts off at negative infinity because it goes forever to the left. What about my range?
0.
Yes, it's back to my range. This is my lowest point, and it's going up to infinity. So you're like, okay, so these negatives can have all kinds of effects here on things, and it can. So like, for instance, let me pull this back down a little bit. When I was looking at number 3, I notice here my difference is I just have a negative 3 that I'm multiplying by. So I can assume at that point that all of my x values that are going in are going to be the same. It'd still be my perfect squares, but now all of these values are going to get multiplied by negative 3. Well, 0 times anything is still 0. But now, instead of getting negative 1, what am I going to get here instead? So we can kind of put this together again. Let's see. Oh, geez, where'd that 6 come from? Got all sorts of fun things going on here. So I start to look, okay, there's all my errors. Oh, yeah. Because instead of negative 1, I'm multiplying it by negative 3. Okay, so I'm thinking, is this going to be negative 6? It is. Negative 3 times 3, I think 9 is going to be negative 9. Oh, we're good. And what happens is my graph is getting a lot wider. Because again, the larger this value is in front, the wider my radical function is going to be. Now, what's that going to mean to me as far as domain and range goes? Let's see. Is my domain going to change between this one and number 3? We're still starting here. We're still going forever to the right. All right. Okay. And then my range, it's the same thing. I'm starting way down here, and I'm ending up here. Oops, boom that up a little bit. So we're starting to see some of the differences that get made with these, depending on the coefficient that's out front. Negatives can flip them down. If they're inside, they can flip them left, and all sorts of fun things like this. So, but again, the calculator helps us out. But notice we haven't done anything yet as far as a transformation, as far as a shift goes. Well, that's about to change. So over on the back then, now we start to get noticing a few things. Now, every teacher does this differently, but I'll show you on the calculator at first, but then I'm going to show you a way I think is actually going to be easier and faster for you. Okay, let's get this guy up here. So we've got the square root. When you have an extra value outside your radical, it's critical that you close your parenthesis. If you forget, you're going to get something really weird. So I got the square root of x plus 1. I'm going to subtract 4. Now, I'm going to notice a couple of things. If I look at the picture, I notice my graph is moved down, and it's also moved left. Opposite of what I see here, left and down. I wonder if that works that way. Well, let's see. Let's try to get some nice numbers here to work with again. So I'm going to plot the points that are coming out as whole numbers. So I see one at -1, -4, at 0, -3. Let's see, at 3, 2, oops. This is why you don't use pen when you do math. At 3, negative 2. Let's clean that up. There we go. Let's see if there's any more that'll fit here. And 8, negative 1. Okay. And I connect the dots. And you're like, okay, that's easy enough. But again, if I don't have a calculator, what am I going to do? Here's the way I want you to think about this. And some of you may decide you're just going to do this and not even mess with the calculator. Back when we did the very first one of these, okay, back on this side, I called number 1 the mother graph, okay, where it's just 0, 1, 4, 9. If you understand that this is the base of any radical that you graph, I'm going to graph those same points on the other side. I'm not going to connect them. I'm going to do it with a different color, and I want you to see what happens. Over here, if I plot 0, 0, 1, 1, 4, 2, and 9, 3, okay? We're going to zoom in a little here, and we're going to take a look at what happened to each of those points. My first point, I went left 1 and down 4. My second point, I went left 1 and down 4. Left 1 and down 4. Left 1 and down 4 from the chart. So when I look at this, this is just my mother graph with a couple of shifts. Whatever value is underneath your radical is your left-right shift. Okay? It's the opposite of what you think. Sort of like when we did the absolute value graphs, the same thing happened. Whatever value's outside is my up or down. If it's negative, it just is the way it is. It's down 4. So when I go to graph any of these, if I understand what my mother graph is, I can go ahead and just make the shifts and not even need the calculator. Now, again, when you have the calculator, I'm assuming you're probably going to use it. But it's one of those things that if I took a second and just think about it, now if some of you go graphing on number 7, go ahead, because I want to show a trick. I'm going to take that mother graph, okay, and I'm just going to keep reminding myself, these numbers don't change. It's 0, 1, 2, 3. But you're multiplying it by 3 this time. Well, now what? Okay, I'm multiplying it by 3. I'm going to multiply each of those numbers by 3. That's my original graph that I do. And what's the minus 1 mean?
You go right now.
Okay. Now, let's play this both ways again. Because I want you to, again, my biggest thing with you every time is that you have options. I want you to do something that makes sense. For some of you, going to the calculator every time with this might make the most sense. So you say, okay, I'm going to graph this. Let's see. Oh, there's error messages. So I'm going to plot my points here. So I've got 1, 0. I've got 2, 3. I've got 5, 6. And am I going to squeeze one more in here? Yep, 10, 9. Okay. So you're like, Harty, it doesn't get any better than this. I'm just going to plug it in, and I'm good to go. But again, I just say, remember, if you're thinking about your original points that you were working with, okay, and we did the multiply by 3 part. I just want you to look at them for a minute, because I always want you to have the possibilities there. Okay, there's my 3 square root of x. There's my mother graph times 3. And we said the shift is right 1, right 1, right 1, right 1, right 1. You don't have to have the calculator. It's nice. I mean, I'll admit it. Typing it in and just copying the numbers. A little bit easier. But if you don't have it, again, it's not a reason not to be able to do it. Or maybe you can even download it at home. Same thing I do here. What are my 2 shifts going to be? Okay, right 2, because again, I do the opposite. These is always my left or right shift underneath, and I see the minus. It's actually the opposite, because it's x minus h. And up 4. But I also notice This one's getting flipped because I see the negative. Okay? It's good for me to understand this. But again, if I go back, we're just going to keep reinforcing it, kind of looking at it both ways. So I got the negative square root of x minus 2 plus 4. All right, let's get some table work going here. Okay, there's my errors. So let's start checking this out. So we got 2, 4. We've got, oh crap, I hit the wrong button. Okay, hang on, let me get back to this. Okay. 3, 3. 6, 2. And 11, 1, just slightly off the screen. Oh, have I been forgetting to do my domain and range? Dang it. Okay, we gotta do domain and range. So, I get that, and again, I think about that as far as my mother graph would go. And one more time, and then I will go back to the calculator, because I think I've kind of reinforced here how this could work. If I was looking at my mother graph numbers, and again, I don't do the shifts when I'm doing my mother graph, it'd just be the negative. So it'd be 0, negative 1, negative 2, negative 3. So you're like, okay, so 0, 0. I go right 2 and up 4. Yep, there's my first point. 1, negative 1. I go right 2, 1, 2, 3, 4, and up 4. So again, I can do it right 2, up 4, and 9, negative 3, right 2, up 4, and get the same thing. So if you understand, again, that concept of the mother graph, you just graph it quick with your numbers that you know are going to come out nice every time, and work it. But let's talk for a minute about domain and range, because I sort of let that get out of my brain with all of this moving around here. What's my furthest point on number 8 that we're working on? What's my furthest point in my actual graph to the left? 2. It goes to infinity. Okay. What about my range? Low to high? Negative infinity to 4. Right, left shift affects my domain. Okay, up, down shift affects my range. I wonder if that works that way every time. Well, let's take a peek here. Let's see if that's true. Furthest point left on my graph back in number 7. 1. To infinity. What about my range? 0. I didn't have any up or down shift. My range didn't move. I shifted right 1. My domain shifted right 1. What a coincidence. Let's check one more of these out. And then we'll play with the number 11 here, and then I think we'll be all right. Domain and range. All right. Furthest point left. Okay. And we're going and going. What about my range? Negative 4. And it does. There's a direct correlation between my shifts moving and my domain and range moving. Left and right shifts flop my domain around. Up and down shifts mess with my range. So let's kind of jam it all in together here now. One last one. Number 11. And again, we'll take a peek both ways here to kind of see what's happening. All right. I don't want to play with the fractions, so I'm turning the 1/2 into 0.5 here. So x plus 2, get that closed, minus 6. All right, let's see what we get here. So we got 1/2 the square root of x plus 2 minus 6. Okay, we're typed in right. You're like, oh, Okay, I see lots of errors up there. So let's see. I see -2, -6. And then all those errors. Okay. 2, -5. Oh dear. Nothing nice till I get that far off. Okay, let's see if I can find something in the middle here. Oh, let's do, we'll take 1 decimal here. 7, -4.5. Okay. You're like, now why did this one, I mean, this almost looks like a line rather than a, a radical curve. The smaller that number in front gets, the skinnier my graph is going to get. So that's one thing that gets a little bit trickier here. But for 11, where are my shifts going to be? What are my 2 shifts for number 11? Yeah, left 2 and down 6. So, okay, so what does that do to my domain and range then? Where does my domain start? -2. It shifted from 0 to the left 2, which on my x would make it -2.
I only have that one problem left.
Okay.
Do you want me to put the chair and the desk back, or?
You can just leave it there.
Oh, okay.
Yep, that's fine. So -2 going to infinity.
Weekend.
Thank you, you too. And then my range goes from bottom. It shifted from 0 down 6 to -6 and goes to infinity. And just like we've done every other time, and it'd be a little bit trickier on this one with the fraction in front, I could take those base numbers, multiply all my y values by 1/2, sort of like up in number 7 when we did it with the 3, except I'd have all of these, so I'd start getting fractional stuff, but I could move and I'd end up in the same places. So, again, take advantage of both ways. Use the calculator when you can, but you also understand this way how the shifts, what's actually going on with these. So your job with this is this guy. I should unzoom a little bit here. Now, this guy, make sure I'm doing this correctly. Yep. Will be our last homework for homework check 5, which again is on Tuesday. So on here, we've got somewhere you're finding the domain and range. Again, if you've got the calculator, great. If you don't, remember, you can always look on the front page of my website. The one that I play with on the computer here, you can have the exact same one. So if you don't have a physical one, that's kind of nice when you're at home. But otherwise, make sure you're working on this and taking a peek at least at those reviews so we can start getting into some questions on those on Monday.